All right, let's look at the ODE homogeneous equations. All right, number one, find the general solution to the equation xy prime is equal to y plus 2 times square root of xy. All right, so first thing I would do is I'm going to divide through by x. All right, so you have y prime. So y prime is equal to y over x plus 2 square root of xy divided by x. All right, and we can simplify this a little bit more because since x is equivalent to square root of x squared, right? So we can cancel x up here and the 1 of the x, right? So what we get is y over x plus 2 times square root of y over x. Right, then you notice that there are a whole bunch of y over x, so we're going to use the substitution. Right, we're going to say let v be y over x. Right, because if you do that, we can rewrite this guy as, right, so here is v, so we have v plus 2 times square root of v. Right? Right. Then what we need to do is we want to rewrite this differential equation in terms of v instead of y. All right. So to do that, I have to find out what the b prime is. So here, first I'm going to multiply both sides by x. You're going to get xv is equal to y. Right? Then if you take the derivative with respect to x, so take the derivative with respect to x. Right, here we have to use a product rule. So derivative of the first guy is 1, so and times v, so you're just going to get v plus x times and derivative of v, so I'm going to write it as a dv over dx because derivative with respect to x, and then derivative of y is dy over dx, but since I've been using y prime, so I'm going to write y prime. Alright, so since this is y prime, I'm going to plug this y prime into the left hand side of the equation. Alright, so what you get, so here's a new equation. We have v plus x times dv over dx. Alright, this is equal to, right, and the right hand side is v plus square root of, actually, I forgot 2 square root of v. Alright, luckily we have a v on both sides, so we can cancel v here and v here by subtracting v from both sides of the equation. Alright, and what's left is actually a separable equation. Alright, so this guy is separable. Alright, so we know how to solve this guy. So I'm going to put all the v's on the left and all the x's on the right. So first thing I would do is I'm going to divide through by 2 square root of v. And also I have to divide through by x. Alright, so divide through by x, x is gone, but we still have to divide by 2 square root of v. And then you have a dv over dx. Alright, so then let's see, so we're going to have, alright, so this is going to be 1, and then divide by x, so you're going to have 1 over x. Right? So we got all the v's on the left and all the x's on the right, so we can take the integral with respect to x. Right? So we take the integral of both sides with respect to x. Right? So we can cancel dx here and the dx there. So we are taking an antiderivative with respect to v. All right. So let's see. I don't like the way it's written, so I'm going to rewrite this guy as this is 1/2 v to the since on the bottom negative 1/2 power. All right. So if you find the antiderivative, you will get this. You have a 1/2 is just a number. Right, add 1 to the power. This is just a power rule for antiderivative, so it's going to be positive 1/2. Then divide by 1/2 is same thing as multiply by 2. All right, so you can actually cancel 2 on top and 2 on the bottom. All right, so that's the antiderivative. All right, antiderivative of the right hand side is just going to be natural log of absolute value of x, right, plus some constant c. Alright, so we can find the v from here. So all we have to do is square both sides. Alright, we get the v is equal to, alright, quantity natural log of absolute value of x plus some constant c squared. Alright, but remember we're looking for y. Y is the solution of the original differential equation. But the v is y over x. So this guy is actually just a y over x. Right? So we can find a y by simply multiplying both sides by x, which is going to be y is equal to x times quantity natural log of absolute value of x plus c quantity squared. Alright, so this is the general solution of the original differential equation. Alright, that's it. I hope that this was clear.